In brief, this is how data alignment works. Data types of a certain size are aligned on boundaries of that size. A 4-byte int is aligned, that is, it starts in memory, on a 4-byte boundary. An 8-byte double starts at an 8-byte boundary. If a single 4-byte int immediately precedes an 8-byte double, as it does in my struct, 4 extra bytes are added after the int to ensure that the 8-byte double starts on an 8-byte boundary. That is, at a multiple of 8 bytes from the start of the struct, with boundaries at 8, 16, 24 bytes, and so on. But when 2 4-byte ints occur, one after the other, they end at a natural 8-byte boundary. So the double is aligned with that boundary and no extra padding is needed. The really important lesson you need to learn from this is that the size of data types cannot be assumed. With different compilers on different architectures, even simple data types might take up different amounts of memory. So if you allocate a specific number of bytes when you write your code on one computer, the program may not work correctly when it's deployed on some other computer or some other device or microcontroller. And if you use complex data types, such as structs, the situation becomes even more error-prone. The way structs are stored in memory is not predictable across different machine architectures. And as I've shown here, even making an apparently trivial change to a struct by reordering its fields may change the amount of memory it needs.